Hello all, welcome back to software testing course. So in the last class we had started the fourth chapter, right? So in that we were discussing about how to design the test cases. So we had stopped till this slide, the different techniques, right? So today we'll get started with the black box test case design techniques. We'll only concentrate on this black box today, okay? So first thing you have to understand what is black box testing. So it is also called as functional testing. Okay. So in this black box testing, we are only interested in the functionality of the software. So we do not bother about the implementation issues. Like we do not bother about which data structures they have used in the code, have they followed the guidelines, what is the file name and all. We do not bother about such things in the black box testing. We are only concentrating on the functionality of the software. Fine. So the test case design is effectively here, it is based on how the end user uses the application to carry out his or her activities with the software. So you have to keep in mind, or you have to have a psychology of an end user, or you have to think like a end user who has never seen this software which he is going to use, and with his that end user's perspective you have to design the test cases. So the test cases have to be easy to read, and it should be understandable so that anyone who doesn't know about this software, whenever they follow your test case steps, it should be easy for them, right? So again, here in the black box testing, as we are concentrating on the functionality, you have to keep in mind both your positive and the negative test case has to be present. Okay, so we have different types of black box testing. So in that we will see about specification based testing, equivalence partitioning, boundary value analysis, decision tables, cause effect analysis, state transition diagram, and use case scenarios. So we'll see these techniques one by one. So in the black box you have these many type of techniques. Okay, so the first one is specification based testing. So in this technique, the test cases are designed based on the specifications. So for each specification, the input values are chosen and the output is checked. We'll take an example and we'll understand what is this one. Okay. So you have, say, suppose the specification of a program is to calculate the roots of the quadratic equation. Okay. So hope you know the quadratic equation, right? So it is ax square plus bx plus c is equal to 0. This is your quadratic equation, right? So we will only take this equation and we will calculate the roots. So consider this is our one of the specifications. Okay, so what do you have to do? You have to read the value of a, b and c. So if the roots are real, then you have to print that roots are real. Then if the roots are imaginary, you have to print the message roots are imaginary. So the program, it need not calculate the roots if they are imaginary. So you choose some test cases such that roots become real, and also some test cases wherein the roots become imaginary. So you will take the test cases now, how you have to give the inputs. Okay, so say suppose you have written a test case wherein the test inputs are a is 1, b is -5 and c is 6. So the expected result of this, whenever you put these values into this equation, the root would be real and root 1 would be 3 and root 2 would be 2. You have to consider another, few test cases with wherein it displays roots are real, and few test cases wherein the roots are imaginary, right? So take another input, so that is the test case 2, wherein you have to give the input as a is equal to 1, b is equal to -4 and c is equal to 4. For this also you will get roots are real. Okay, then you have to consider another test case wherein you have to print the message that is roots are imaginary. So you have to choose inputs like that. Okay, so whenever you give input as a is equal to 1, b is equal to 4 and c is equal to 8, so you will get a expected result as roots are imaginary. Okay, so in the specification based testing, Specification is nothing but a functionality. Okay, so to test that functionality, what you have to do, how you have to write a test case is like both positive and the negative testing has to be carried on that particular functionality. If you consider login functionality, the positive testing would be your username and the password is correct. Your negative test case would be, there would be three negative test cases for this one. Okay, one is like your username is correct, password is wrong. The second one, username is wrong, password is correct, and in the third case it would be like both username and password it is wrong. Fine. So this is how you have to this is how you have to have a or design the test case for specification based testing. So next we will talk about equivalence partitioning. So in this equivalence partitioning, all the possible valid inputs and valid outputs are identified. So the test cases, it consists of both valid inputs and invalid inputs. Okay. So here first what we have to do, we have to form the equivalence class. That means for one class it has valid inputs and for another class it has valid outputs. So we say that a group of test cases, they form the equivalence class if all the test cases that test the same thing, and if we say that like in one of the test case or in one of the test in that group it finds a bug or it catches a bug, then all the test in that particular class will catch the bug. If none of the test in the group it does not catch a bug, then we say that none of your other test cases that are in that group will not catch the bug. So we'll consider an example here, that is you have a program that finds the square root of the integer. Okay, whenever you have this program, how do you test that for the equivalence partitioning? So while testing, if you give the input as 4, suppose the correct result is obtained. Okay, you can generalize that and say that for all positive numbers the program will work fine. Okay, and suppose that you have given an input as -4, then the program gives you a runtime error. Then you can say that for all the negative integers the program won't work correctly. Okay, so here there are two inputs, whatever the example we have just seen, right? So all positive integers it will form one class, and all negative integers it will form another class. So we have two classes now. Whenever you give all the positive integers for that program, you will get the square root of the integer. But if you give any negative number, then you will get a runtime error. We'll take another example wherein say suppose you have a program that takes three numbers as the input and it checks whether those numbers whatever you have entered will it form a triangle or not. Okay, now here you have to find the classes, right? Equivalence classes. So there are two possibilities here, that is a set of numbers that form a triangle will form one class, and a set of numbers that do not form a triangle will come into another class. Say suppose you have given the input as, I'll write here, you have given the input as 3 3 3. Now this will form a triangle. So again you have given a number like 3 4 5, input says 3 4 5, again this will form a triangle. But say suppose you have given 0 0 0, input as 0 0 0, so this does not form a triangle, right? So these two things, or any number which comes in this class it becomes, or which comes in this group becomes one class, and anything that comes in this group it is called as another equivalence class. Or say suppose you have another number 318, again this does not form a triangle. Fine. So for all the test cases, right, these all becomes your test cases. Okay, so the entry criteria is that program should wait for the user input, and the exit criteria is that program should terminate or it display the proper messages. Say suppose you have given for the same program finding triangle, so you have given the numbers like 78,000, 32,000, 1,80,000 as the inputs, three inputs. Then what will happen? So you should get a proper error message, that is the numbers are too big and it cannot be handled by the program. So something like you should get. So your program should not, it should not hang or it should not exit unexpectedly. So whenever you have different types of inputs, so those form a equivalence class. So this is one equivalence class, this is another equivalence class, and the third one is like your large numbers, 78,000, 32,000, like that. Okay, again, so for equivalence partitioning, I'll give you one more example, which is the basic one, that is the login screen, right? So if you give correct username and password, then you'll log in. Otherwise, the login would be unsuccessful. So many users can log in into the system using your login screen, right? So it is not enough that if you test for one particular credential and you leave and you won't test for other things. Okay, so you have to make sure that you from different, password combinations or the username combination for multiple users, you need to log in, you need to give the credentials, and you need to test. So each user will have a username and password, right? So you need to give multiple usernames and corresponding passwords so that so that you can test the login form. So carrying out a test with multiple data values, we call that as data driven testing. So for that, you need to have a database, basically a excel sheet which has username and the password. Okay, and you have to enter multiple records in that excel. So you need to write a test script such that each record it substitutes the values of the username and the password and checks whether the login is successful or not. So you need to apply equivalence class partitioning here also, and you have to test for both valid and invalid inputs. Say suppose the name John, and this is the username, and Mary. Okay, 1 2 3. So if this is a correct username and password, so whenever you carry out the testing, so if you give this username and password, then the login has to be successful. If suppose you have given something like this, capital J H J O, something like this you have given. Okay, so this should result in a unsuccessful or error message has to be thrown. Why? Because J is capital here. So we had considered this as the original or proper credential. If you make any changes to the username and password for this one, you'll end up having a error message, right? And say suppose if you try to give only the name and no password, or if you give password and no username, something like this, the different combinations you try out, right? So that will become your equivalence class. Okay, so in our case for the login screen, this is our one equivalence class, that is the correct username and password. All other different categories, right, whatever we have discussed now, correct username, wrong password, anything you do, so that becomes your another equivalence class. Okay, next we'll talk about boundary value analysis. So in the boundary value analysis, you need to identify the boundary values for the inputs at which the software is likely to fail. Okay, so say suppose you have a program which takes the input as 1 to 100. Okay, there is a text field, it takes the value 1 to 100. So you have to check for the boundaries here, like if you give 1, what will happen? If you give 0, what will happen? If you give 2, what will happen? And the same applies to the maximum number as well. 99, you give 99, then 100, then 101, what will happen? So this becomes your boundary values. Okay, so let us consider an example. Suppose you have a form GUI wherein you can enter the employee details like employee name, then his department, his salary. So these all things can be entered into it, and once you click on submit, it would be stored in the database, something like that. Okay, so you need to test the salary field here. So say suppose the salary field is declared as an integer, and that takes the values from 1000 to this one 65 535. So how do you do a boundary value testing for this one, right? So first you have to give the boundary values for the this one maximum value 65 535. First you have to give this value and check whether your record can be saved. Okay, then you have to give a invalid boundary value like 65,536. Give this value and submit the form. Check whether you are getting an error or not. So if the error is coming, then it is properly handled, the code is properly handled. If not, if this is saved, then it is a problem, right? So now this becomes your upper limit. Okay, then you have to test for your lower limit. Say suppose 1000 is the minimum salary. So if you give 999 and then click on submit, what will happen? Will you get an error or not? So check for 1001, and again you have to check for 1000 as well. Okay, boundary value in the sense whatever the upper and the lower limit you have, right? You have to do -1 and +1 for that. So that becomes your boundary values. Let us consider another example wherein the boundary value concept it can be applied to the string constants as well. Suppose the employee name it should have at least 10 characters long and maximum of 30 characters is allowed. Okay, employee name field it has minimum 30 to maximum minimum 10 to maximum 30 characters. Now you have to check by giving 9 characters only, then 10 characters and then 11 characters. Here 31, 30, and you have to have 29 as well. You have to check for all these conditions, like 6 values you need to give and test whether your program is working correctly or not. So this is your boundary value analysis. So the next one is decision tables. So this decision tables are used when there are many conditional executions. So the test cases need to be selected to ensure that all the conditions are tested at least once. So I'll give you an example for this one. So say suppose we have this income tax rules. Okay, so the income tax paid it depends on the whether you are a male or a female or you are a senior citizen, and it also depends on their salary. So say suppose here the salary is less than or equal to 1 lakh, then if he is a male, then 5% would be deducted. Then female 2% would be deducted, and if it is a senior, he is a senior citizen, it is not tax is not deducted. If it is less than or equal to 2 lakh, this rule applies. So this is your basic income tax rules which has multiple conditions here, right? So when you test this particular software, you need to ensure that at least one test case is chosen for every true false condition in the table. So for example, you need to choose the test cases for an individual male. Okay, I'll consider this one. So with the salaries less than or equal to 1 lakh, less than or equal to 2 lakh, and greater than 2 lakh, you have to check all these conditions. Again, for this condition, you have to check true or false whether give salary less than 1 lakh or equal, and then you have to give the salary greater than 1 lakh. Then again, you have to give the salary which is equal to 1 lakh. Okay, so likewise, you have to test. So you need to use a boundary value analysis to design these test cases. So the boundary value for the salaries is like your 1 lakh and 2 lakh. These are the boundary values, right? So you give less than 1 lakh, equal to 1 lakh, equal to 2 lakh, and greater than 2 lakh. And if you consider, right, the senior citizen is there here, right? The say suppose senior citizen age is 65. So whether the 65 is a if a person has years as 65, age is 65, whether he is a senior citizen or not. So here the programmers they tend to make mistakes when the numbers are given, right? So if a person who is just 65, he has just he has not completed 65 years, but he is just 65 years, then whether he is a senior citizen. So that causes confusion, right? So this confusion might be because of the specification is not clear, or the developer has not clarified his doubt, something like that. The issue may happen. So either ways, your boundary value analysis. Okay, in the decision table also you have to make a boundary values, right? Here you can see the age is less than or greater than 65, equal to 65. So these becomes your boundary values. So this boundary value analysis and your decision table whenever you have, so that yields many test cases. That means that yields or it detects more errors. Okay, so the next here is the cost effect analysis. So in this approach, for each input, each cost, we say input as cost, there is a action or a effect, and it is identified, and a cause effect graph is drawn here. So this graph in turn can be converted into a cause effect table. Whether then the table can be used to generate the test cases. So we'll consider an example of withdrawal form verification in a bank account. Okay. So here we can have three causes. These are just an example. Okay. So if your account number is correct and you have signature whatever signature you have put on the form is correct with that of the database, and enough money is available in your account, the customer can get the money. Or if suppose enough balance is not there in the bank account, the customer is informed that there is no proper balance or enough balance in his account. Or if it is a fraud case, you can call the police, right? So each of these causes, like cause 1, cause 2 and cause 3, these can be true or false. If the account number is correct, if the cause 1 is correct, you can check for the enough money is available or not, right? If the account number is incorrect, then you do not proceed further, right? So the for various combinations of these causes, the action or the effect can be taken. These are your actions, right? So you have to have these causes can be again true and false. Based on this combination, these actions would be taken. So the test cases have to be generated in such a way that all these causes are true and false. So for each test case, it has to be checked whether again right action has been taken or not. Say for example, the test case 1 would be your account number is correct, your signature matches, and you have enough money. So all these are true. Then what will happen? You can get the money, right? That becomes your test case 1. Then your test case 2 is like there is correct account number, signature matches with the bank database, but there is no enough money. Then what should be done? You should not give money to the customer, right? Then your third case test case would be account number is correct, but the signature does not match. Again, you have enough money. Whenever this happens, again you should not give the money, right? So again, this is one combination I have taken. You can have multiple combinations for the same thing. I'll give you one more example. In the same thing, say suppose you have one more test case like incorrect account number, signature also does not match, and there is not enough money in the bank account. Then what you will do, right? So whenever there is account number is only wrong, how can you match the signature with the database? Then how can you check whether there is enough money in the account or not? So this test case is little difficult to handle, correct? So whenever you have this type of test case, what you have to do, you have to search for extra information. In our case, we'll search extra information in the withdrawal form, whether the if the account number does not match, whether the account holder's name matches or not, address matches or not, any other details can be checked out here. Fine. Okay. Then we'll see about the state transition diagrams. So the state transition diagrams are extensively used to indicate the different states of a system, from one state on state to off state. Suppose it is a fan, right? So it is in on state, or it is in a off state, or it can also be in a running state, maybe, right? So these state transition diagrams, these help in choosing various test cases. So you need to ensure that each and every test case is every state is tested in this particular state transition diagram. So for example, we'll consider a private branch exchange, call processing software. So in this software, you can dial a extension, say suppose 3-digit number. Then when you type in or when you press all these 3 digits, you can establish a call. Okay. So basically, what will happen? This is a call processing system, right? So initially, consider your landline. It would be in a on hook status. So whenever you want to make a call, you lift the receiver. That is lifting of the receiver. It changes the state of the uh, call or your phone. So basically, it would be in a on hook status. Whenever you take the receiver, it would be in a off hook status. Then you can dial a number. You can disconnect. So what are the different test cases here? The first test case would be you can from on hook, you can go to off hook, and you can discontinue or disconnect. Okay. So this is your first test case. Second test case is go off the hook, dial 1 digit and then disconnect. This is your second test case. So again go off hook, dial 2 digits and then disconnect. This is your third test case. Likewise, you have 6 test cases in this particular example. So in a practical call processing software, you need to handle the dialing of the wrong numbers as well. You need to keep track of the duration of the conversation and the time and day of the conversation. Also, you have to take care of updating of the billing in the database with the records of a particular call. So this is just a theoretical thing, right? So in the practical, whenever you are gonna actually test it, you have to consider these many cases apart from these 6 test cases. So the last one is use case scenarios. So these use case scenarios are the series of action that a user is likely to take while using the software. So you already know what is a use case. So use case scenarios are nothing but the functionalities or the actions, whatever your end user performs whenever he tries to use a software. So the test cases can be designed in such a way that all of these actions are performed one after another and the desired result is obtained. So let us take an example wherein you have to test a banking software. So something like this. This is your diagram for this banking software. Okay. So the use case is the customer. Okay. This customer gives the check to the bank employee. Okay. This customer gives the check to the bank employee. Then the bank employee verifies the bank the check with the bank database. So this check would be verified with the bank database. Then the database will give the response indicating whether the check is valid or not. So if it is valid, then cash is given to the customer. If it is not valid, then it is the cash is not given and the same message would be given to the customer, right? Now, these are the series of actions that would be carried out by a customer and your bank employee. Now, the test cases have to be written in the same manner, in the same series. Okay. So, whenever you are doing a use case testing, we need to generate test cases for validating the check by using again equivalence partitioning, boundary value analysis, and cost effect analysis. Okay. So these are the different techniques in your black box test. That's it for today. We'll conclude our session. Thank you.